Test plan involves option A test cases, B DFD, option C testing methodologies, option D none of these. Actually, for planning any test of a software, we require to have the test cases. Actually, data flow diagrams and the testing methodologies are not required. So testing methodologies are required at the time of testing, not when you are planning. For the test plan, we have to consider the different test cases, and then the plan will be taken out. So that option A is the right option. Type of protocol is HTTP. Option A stateless, option B stateful, option C semi-stateful, option D none of these. Here HTTP protocol, that is hypertext transfer protocol. HTTP means hypertext transfer protocol. This protocol we are using in the World Wide Web for browsing any website. In order to get the text pages we used to access in the website, we used to have this HTTP protocol. This does not maintain any state information regarding this request, so that it will be a stateless protocol. HTTP protocol is a stateless protocol. Option A is the right option.
A matrix is given, and it is given that it has one eigenvalue 1, and we have to find the value of k here. So if we write characteristic equation for this, we'll be getting as determinant of k minus 1, k minus lambda 1 2 1 2 minus lambda k 1 2 3 minus lambda. Determinant of this matrix should be equal to 0. Here lambda is an eigenvalue, and lambda is given as 1. So if we substitute this lambda is equal to 1, we will be getting as determinant of k minus 1, 1 2 1 2 minus 1 1, this is 1, and here k 1 2, this is 2, and this is 3 minus lambda is 1, so this will become 2. So determinant of this matrix is should be 0. So if we simplify this, we will be getting as 2k square minus 5k plus 2 is equal to 0, which implies 2 into 2k minus 1 into k minus 2 is equal to 0. So here k is equal to 1 by 2, or k is equal to 2. So here one of the options is 1 by 2. So here correct option is option A.
Circuit has one input and one output. In the input sequence, whenever a pattern 010 or 0001 is detected, the output becomes 1. Otherwise, output equals to 0. What will be the minimum number of states or equivalent states? Minimum number of equivalent states required in the synchronous sequential circuit. State diagram of a synchronous sequential circuit. See, here first of all, I am indicating a state with S0. So if input pattern starts with 1, it is going to stay in this itself. But if the input pattern starts with 0 input bit sequence, it goes to the next state S1. This is 0 by 0. If the next, again in this state, two possibilities. If it is 1 at this particular state, if it is 0. If it is 1 means it goes to next state, that is S2. If it is 0, next state, that is S3. Again at this S3 state, if it is equals to 0, here this is the state diagram corresponding to this one. Okay, now Here 0001, whenever a pattern 001 is detected, it comes back to S0 state because it has detected the pattern and it giving the output 1. If 010 is detected, it coming back. Similarly, if at S4 state, after getting 3 zeros, if it is getting one more 0 means the pattern is not going to be detected, but it consists of 4 zeros continuously. So we can consider these 3 latest zeros as a part of the pattern. So after getting 3 zeros, we are entering into the S4. So we have to make it again to S4 in that way. If it is 1, the pattern is able to detect, so it comes back to the S0 state for the detection of the next pattern. Hence, this state diagram, which is able to detect 2 patterns which are present in the input bit pattern, that is 010 or 0001. Hence, it consists of 5 states, that is option B is correct.
A computer has 32-bit instructions and 12-bit addresses. Suppose there are 251 two-address instructions. How many one-address instructions can be formulated? Options are 20,480, option B 24,576, option C 4,096, option D 1,31,072. So here the instruction size is 32 bits. Let us suppose if the instruction size is 32 bits, if we represent with two address instructions, for example, we can have the opcode, which is compulsory in any instruction, and followed by the two addresses, that is address part 1 and address part 2. If the format of instruction is like this, for example, the total number of bits required is 32 bits for each instruction. So here, if address is taking 12 bits each, then address 1 takes 12 bits, address 2 also takes 12 bits. Total 12 plus 12, that is 24 bits are reserved for only address. So out of this 32, if 24 bits are reserved for address parts in the two address instructions, then remaining bits we can use for the opcode is only 8 bits. 8 bits we can use for the opcode. Using 8 bits, we can perform 2 power 8 different operations. That means 256 different types of opcode are possible actually. Out of these 256, only 251 are used for the two address instructions. So out of this 8-bit combination in the opcode, we have taken already up to 251 combinations. So what are the remaining combinations available? That is 256 minus 251. Only 5 combinations of the codes are available. And also it is asking that how many one address instructions can be formulated. That means only one address is possible. That means only one 12-bit address. This address is also can be used as a opcode here. This 12-bit first address can be used as opcode. So the remaining 5 combinations in the two address instructions into these 12 bits, which we have reserved for the address part in the two address instructions, can also be used as opcode, so that it will become 5 into 2 power 12. That is 5 into 2 power 2 into 2 power 10, we can write like this. So this is 20 into 2 power 10. That is 1024 into 20. So it is around 20,480. That is option A. 20,480 number of one address instructions can be formulated when you are using the first address as a opcode, when you are extending. The remaining combinations 5 in the second address instructions, and then these 12 bits 5 into 2 power 12, which is equivalent to 20480. Option A is the right option here.